All right, 2.4b, we have 4 examples we're going to look at. All right, so this first example, where it's f of x equals 3x plus 2 over x minus 1, all the directions are saying is I want you to find the derivative of this function at that point, at the point 0, negative 2. All right, so let's go through here. Well, if I'm going to take the derivative here, I notice that it's divided, and then I have an x on the top and I have an x on the bottom. So because I have an x in both spots, I'm going to do the quotient rule. All right, so quotient rule says, write down the low term, take the derivative of the high. So the derivative of the high term is just going to be 3, minus, write down the high term, and take the derivative of the low term. So that's kind of nice because that's just a 1, all over that low term squared. All right, so there's the derivative. Now we just have to clean it up. Distribute the 3 gets me 3x minus 3. Distributing the negative gets me a minus 3x minus 2 all over x minus 1 squared. And if I take that another step, those 3x's cancel out, so that's kind of nice. So then I have negative 5 over x minus 1 squared. But now I want it at that point, 0, negative 2. So I'm just going to take 0 and plug that in just for the x. So if I plug that in for x, I end up with a negative 5 over 0 minus 1 squared. So negative 5 over 0 minus 1 squared ends up with a negative 5. So my derivative, or my slope at that point, is negative 5. All right, so the directions again, I want the equation of the tangent line of this function at that point. So whenever it says equation of the tangent line, remember you have to take the derivative first. So don't be plugging in anything, don't be doing anything yet. Take the derivative. And when I see this problem, I'm really going to rewrite it to be 3x squared minus 2 to the 1/2. Now it's set up for me to take that derivative. All right, so my derivative is going to be a chain rule situation, so I'm going to power down the 1/2, again being deliberate with what's in the numerator and what's in the denominator. So 1/2 times 3x squared minus 2 to the negative 1/2. But now my chain rule says I powered that down, but now I got to take the derivative of the inside. So the derivative of that inside is 6x. All right, so now if I clean that up a little bit, that 2 and that 6 is going to cancel, and that x is going to stay on top. So my derivative is going to be 3x over, and if I move that to the bottom and put it back into a square root, I get 3x squared minus 2. Okay, so there's my derivative. Now I actually have to go through and plug in at that point. So now at 3, 5. So if I plug 3 in there, I get 3 times 3 over the square root of 3 times 3 squared minus 2. So that gets me 9 over 27 minus 2 is 25. The square root of 25 is 5. So my slope is 9/5, which is fine. We don't have to make it any harder than we have to. There's my slope. There's my point. Let's write the equation of the tangent line. So I'm going to have y minus 5 is equal to 9/5 times x minus 3. All right, so again, writing the equation of a tangent line, don't be plugging in anything yet. Okay, we're going to take the derivative. But when I see a problem like this, I'm going to rewrite it to kind of help myself out. I'm going to rewrite it tangent of x squared. Okay, so now my chain rule says power that 2 down, but keep this exactly the same. Just lower it by 1. Now take the derivative of the inside. Well, the derivative of tangent is secant squared. Notice that it's x, x, and x as my argument. Now my chain rule says take the derivative of the argument. Well, the argument is just 1, so that's kind of nice. All right, so now I have a derivative here of 2 tangent x secant squared x. There's my derivative, but I want it at this point of pi fourths 1. All right, so I'm going to plug pi fourths in here now. So now I have 2 times the tangent of pi fourths times the secant of pi fourths. And I'm going to treat it, instead of secant squared of pi fourths, I'm going to do secant of pi fourths, and then I'm going to square it when I calculate that. All right, tangent of pi fourths is just 1. Secant of pi fourths, go back to timed quizzes, or you could draw a triangle. You actually get root 2 squared. So 2 times 1 times root 2 squared. Well, root 2 squared is just 2. 2 times 1 times 2. I have a slope of 4. So there's my slope, there's my point. So my tangent line is y minus 1 is equal to 4 times x minus pi fourths. All right, so this notation here, f double prime, that means find the second derivative. So I'm going to take the derivative of this, and then I'm going to take the derivative of the derivative, and that's going to be my second derivative. Okay, so here, see how there's no x on the top? So if there's no x on the top, we're not going to do quotient rule. Remember, quotient rule has to have a variable on the top and the bottom. So here, I'm just going to rewrite that. So I'm going to rewrite my function to be x minus 2 to the negative first. Okay, now I'm going to go through and take the derivative of this. So my derivative says, let's power that down in front and lower it by 1. And then take the derivative of the inside. Well, the derivative of the inside is just 1, so we don't have to worry about it. Okay, now I could rewrite this to be negative 1 over x minus 2 squared. The problem, though, is then I have to take the derivative again, so I'm going to have to rewrite it and move it back up. So instead of rewriting it twice, I'm just going to leave it like this and take that second derivative. So second derivative says, power down, that makes it a positive 2 now, x minus 2 to the negative third times the derivative of the inside, which is just 1. But now, since I'm ending at the second derivative, we do need to rewrite that. So my final answer, my second derivative, is 2 over x minus 2 to the third. All right, that's it for 2.4b. See you guys.